In this video, we're gonna focus much on ray diagram. After watching this video, we'll be in a position to know an optical axis, so optical center, in a central ray, principal ray, in a principal axis, and we will know object distance, image distance, magnification, so nature of image, so we'll be in a position to know focal length, principal focus, which sometimes is called focal point, and some other things as we move along. So let me start by defining this guy. Optical axis, that one is defined as the center of a lens. So pachatindi malenzi magulawire tindi temati concave lens, adawa amapangitsa malenzi aja kuti light rays kuti they should diverge, they should not meet, something like this. Whereas the convex lens, that one malenzi amapanga converge, they meet after passing through it. So I should have this guy, convex lens is the one which I'll be using. So that's the convex lens, something like that. So a principal axis, not principal axis but optical axis, is the line which passes through the center of our lens. So that red line, it is indicating the optical axis. So this is optical axis. So that's the thing. And we have a principal axis. A principal axis, this one is the line which is perpendicular to our optical axis. So let me have my rule again, and I should draw a line which will be perpendicular to our optical axis. So this line here, blue line, that's our principal axis. Now I should divide this one into equal length. So let's say this one, that's 1, 2, 3, as a 1 here. Let me change the color. You should see we have 1, and we have 1, 2, 3, 4, and 1, 2, 3, 4 there. So this side here, 1, 2, 3, 4 up, and 1, 2, 3, 4 somewhere there, and 1, 2, 3, 4 up, 2 centimeters. And that's going to divide into 2 centimeters. These 2 centimeters, they're representing focal length. So a focal length is the distance from the lens or mirror to a focal point. So the distance between optical axis to the focal point. So that's the thing. So I'm labeling this one as F. That's focal point number 1. Focal point number 1. And we have another one, focal length, not focal point, but the focal length. This one 2F, and this one 3F to the right. Whereas this one here, that's F to the left, 2F to the left, and this one 3F to the left as well. So a point where principal axis meets optical axis, this point here, that one is called optical center. Now tiyambeni tsopano kupanga indicate positions of image and object along principal axis. So this one, that's our principal axis. Now what can happen if we place an object at f? Chinga chitike nchani tirasiya object ife pa f. I mean, I should start with 2f. Let me take my ruler and place my object at 2f here. So this is my 2f, and the height of this object, let me choose, should I have 2 centimeters? No, ningoiga adawa at least irekize pamene something like that. So this is my object, and I should draw a principal ray which passes through the edge of our object. So I should choose another color. This time I should take blue, indicating principal ray. Then after passing through optical axis, imapanga bend kene go makadutsa pa f. So that's the line, it bends there going this way, you see. And we have this guy, central ray imadutsa pa edge of that object ndikudutsa pa center pamene ndikupanga lifa kuti ndi pa optical center. So it passes there, something like this. And this one tijambule line ya red, should be red, yeah, idutsa hapo ikapita huko. So a point where a principal ray, focal ray, commercial central ray meets, pamene we have our image. So you can see with the image ife is around here. So that's where we have our image. So ndakamba za focal ray imadutsa pa f hapa, it passes through f. So which color can I choose? Can I take black? Yes, black representing focal ray. So idutsa pa f hapa, then oku ikadutse nawo apo ikapange nawo miti pamenepo. I think sinadutse pa f, kubano should be around there, yeah, at least around the igwira. And we have this one, yeah. So that's my point. Ababa pamene pali object, I mean image ife. So this guy, that's principal ray. The red line, that's the central ray. Whereas this guy, that's the focal ray. Right? An image has been formed by 2f, and if you can measure the height of our image, you can see it is equal to the height of our object. So this one, that's 2 centimeters. I'm referring to 2 centimeters. Also, you can see ikufanana. If you can count hapa, tende 1 aga, 2 aga, 3 aga, 4 abo. You see, 1 2 3 4. Similarly, uku tikana also 4. Teri wilenge tibeze kanso 4. Let me take blue to elenge mods. You see we have 1 here, 2 here, 3 here, and 4 pamenepo. So this is what happens when you place an object at 2f. Or if you place an object at 2f, image imakapangidwa so form at 2f. Object at 2f, image also formed at 2f to the other side of our lens. That's what happens. What about the image distance and object distance. If I can draw a line here, it will say up, and you should measure this line. So let's measure this line together. Yeah, something like this. You can see we have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 8. What about this side? This side as well. So 8. So this is the line. Line. If we can count, we have this guy up 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this line here, that's our object distance. Whereas this line from optical center to where there is an image, image distance denoted by letter V, whereas this line here, that's object distance denoted by letter U. So the nature of image, if we place an object at 2f, nature yake imakhala same size as the object. Current has a good, if you can measure magnification, the answer will be 1. So magnification formula. Magnification, we just do V, which is the image distance, divided by U, which is object distance. This one, that's 4 centimeter. So we have 4 centimeter. Have also tinawelenga 8 centimeters. So we have also 4 centimeters. So if you divide this one, that's 1. So magnification, that's 1. That's what we do. What happens? Similarly, you can also find the magnification if you divide the height of image divided by height of object. So tinapanga measure kuti kaupanga approximately 2 centimeters. So you have 2 centimeters divided by this one as well. Inaweza so within the 2 centimeters. If you divide this, you see the magnification will be equal to 1. It's the same thing. So without drawing the lead diagram, what is the nature of the image? If an object is placed at 2f, same size as object, magnification answer again 1. So whenever an object is formed at the other side of the lens, like this one, object image imakala upside down. You see? So the image is imakala inverted. The image is inverted. So this side here, makandi screen effect. So when an object is, when an image is formed on the screen, that one, that's a real image. Real image is formed on the screen. The opposite of real image, virtual image. So that's the thing about the array diagram when we place an object at 2f. What about if we place an object between 3f and 2f? Chinga chiriki nchani teri dibange place our object pakati pa f 2f and f. What will happen? Let's see. I think I should place it around there. So let me take my ruler and then they say up. So height ikale 2 centimeters. So that's 1, 2, 3 up. Kenako please pole it say up. Yeah. Then ogu make sure you do say power 1 forward to the light. So we have there that's our principal lay. kenako a central idutse pa focal, not focal but optical center. We have optical center, so that's the thing up lula so kudelera. Come on, yeah, let's have that one. And I should take a red color, so the line passes through there, yeah, something like that. And this time I don't think it will in the jumbling, so it's interesting how we come on. What's very important, it's only principal lay, commercial central lay. They're the ones which are very, very important. Ada wa si wini weni. I mean, do I jambula power? Immediately focal lay. So we again. So we have that one. You can see with these things, they are meeting here. You see, they are meeting there. So if you can measure object distance, let's measure here object distance. So we have our distance there. Let's measure that one to what's the thing. So if you can count, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and yeah, should be 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, around 11. 11. Tima half triple 11. So tima half 11. This side here where we have our image. So let's measure there our image distance. So let's count together. We'll see with the tone. We take another color. We take yellow. So we have 1. Yeah. So we have 1, 2, 3, 4, 5, 6.5. You see? Ogu tilipo 11. This guy tilipo 11. Pomo ogu this side tilipo 6.5. Tima half tilipo 6.5. What you gonna do? You can see with the image distance is smaller than object distance. So if you can calculate magnification, let's say formula to generate magnification. Magnification is equal to V divided by U, and V, that's 6.5 centimeters, then divided by 11 centimeters. So if you can take our calculator and take 6.5, let you see this, 6.5 divided by 11, you see the answer you will get 0.591. So you have our magnification as 0.591. That's our magnification. What about if you can measure the height? If you can measure the height of the image as well as the object. So let's measure this height here. So we have 1 kahaf number 1 and kahaf number 2. Whereas this uku tindi timahafu ringati tindi half 1 2 3 timahafu titatu. You see, tindi timahafu titatu. So those 3 halves they're representing 1.5 centimeters, and those 2 halves they're representing 1 centimeters. So if you can calculate magnification using this formula, which says that image height divided by object height, so this is our image height, which is 1 centimeter divided by 1.5 centimeters. If you can divide that one, so let's take our calculator, divided 1 divided by 1.5. The answer is 0.66. So to the next single card 0.6. You can see it's similar to this. Chabe gote lula waine sa ugoni tsama centimeters anaipanga ya infinity. That's why sana banka indicate. Komano mukabanga pa mukazibanga niyo using your ruler. Ngati mende kubangire nemu. Mansala makalofana na mfuno msafone. So that's what happens when we place an object between 2f and 3f. Magnification imakhala less than 1. It means an object is diminished. The nature of image, that's diminished. The image it's smaller than object. You see? So magnification, that's less than 1. And another nature of image, still, since the image has been formed to the light hook, that's how a real image before it has been formed on the screen. That's another nature. Ndimene munga magere zimene zizi pamesoma tukufusani nditu. Use a ray diagram, show the position of image, or you can be asked to complete the ray diagram. So mangoona kuti zizili kanjani. But it's a clear indication that whenever we go this side here, placing an image object, you're placing an object this side, image imabwelera oko imatsaro, therefore chimankanijeba. So if you place it here, don't expect that the distance will be the same as this. No. Command what will happen, the distance will be decreasing if we keep on placing the image far from the center of our lens. That's what happens. What happens if we place an object at f? Tuone kuti chinga chitike nchani tidapanga place our object at f. Let's draw a ray diagram indicating an object placed at f. So if we place an object at f, let's have our object. Still we should use that one with 3 halves. So this is half number 1, number 2, number 3 per minute. And our principal A, we're going to lose a percent up, something like this. It's up, kind of wake up bender. So up, we're going to do something like this. Yeah. Okay, yeah. So that's our principal lay, and we should have a central lay. Central lay imadutsa pa optical center. So let me take another color black. Let's see if these lines can meet. You see, these lines no longer meet. So this is kumana. You see, so good malaina mini wakumana. Never mpaka na mwana mulungu adzabwere. These lines can't meet. You see what has happened there? You see, you can see these lines sanga kumane, they are parallel to each other. You see, atakufusani what happens when we place an object at f. Yankho yake timana kuti image is informed at infinity. We have infinity. That's where we're gonna have our image. Mwanjire say image simoneka. Ngati lens je chimongonika china chake jambu ya something like that. Tikagwitsa ntchito lighted. Sichimoneka chinthu cho. That's what happens. Akazafunsa nikuti complete the ray diagram. Atongojilegeza pamene papa. Something like this. Ngokuyikira ni ray diagram. Kaijeni yoncho koneka nchikuru mmalizitse. Don't ever try kuti zinthu zozikumane. Never. Zinthu zozo sizimakumana, musadzalekeze. So that's what happens when we place an object at f. What about if we place an object between the lens and the f? The rant was between here. Chinga chitike nchani if you place an object there. So chumudipange I think ningoika around here. So we are using 3 halves. So we have our object, same height, 3 halves, half number 2, and this is half number 3. So our line, which is the principal lay, idutsa apo kenako ikadutse pa F. Yeah, something like that. Ikadutse uko tione kuti chichitike nchani if we place an object between F and our lens. So this is our object. So if you can draw a line here, idutse this line paja tumaicha kuti central lane. So let me take another color, and this line should be blue line here. You see to the light of our lens sizugumana komano these lines I think they can meet this side here. Tikatenga principal A ndi central A, you can see they are meeting to the same side where we have our object. So apo around there. Question hii inafunzida 2013 physical science asa napange split. You can see kuti zinthu zakumana at this point. So we have our point there where these lines are meeting. So I think I should take another color red. We have something like this. This is our image. You see? Apa conclusion omwe mapanga, when an object is placed between F and the lens, image is formed on the same side where we have our object, and that image imakhala magnified. As you can see, this one it's bigger than this one. You see, no need to calculate magnification. You can just measure or calculate magnification. Kwanu kumungu aisi, right? In how we sindilola kulila should also calculate magnification. In how we sindilola. So you can see this one magnification definitely greater than the size of image, which is HI. Magaza divide in the HO. Magnification yake is greater than 1. That's what I'm trying to mean up. So that's the thing. 2013 anatifunza time nayo kuri we should find the not finding but completing the diagram. Anangofunza kulekera anangochika chonchi something like this kuti fedi malizitsi. Nde ngati ndata mulibe kwanira muthu akazipangitsa zinthu zokuti zikumane this side. Komano apa ndafuna ndikonze kuti zoneke icho mwecho. I think placing an image here, between here and here. You can demonstrate this. So you can keep on practicing these things. Hello my guys, this is what I prepared for you. Positioning of an image and the object. When you place an object, position of image when you place an object. 3F between 2F and 3F between 2F and F. Yeah, nimeni tima vangira hapo. Tone ngati ndamisa chinthu I think sinamisa kanthu hapa. Principal A ndakuza ni central A ndakuza ni optical center ndakuza ni object distance, nature of image ndakuza ni. Komano yomwe na jambula hapa yet mutha kufunsidwa kuti you should find the nature of image. This guy here image yaife Simone kapa screen. You can see screen makala this side. Ready? Komano apapa chintu chikupangidwa form to the side where we have our object. Nature of that image imachidwa kuti virtual. It's a virtual image. It's a virtual image. A virtual image is the one which is not formed on the screen. Komanso imakala upright. Notice inverted is it. You can see it's upright. Chiri komwe koko imakala upright. Pomwe when an object, when an image is formed this side, imakala upside down. So that's the thing about these things. I think ndakire pomwepa ngati pali mafunso ndikuti you can text me ku Facebook tione kuti tingamvane motani yet. Komano please don't forget to subscribe to my YouTube channel as well as like in my Facebook page, Unique Online Classes Malawi, if you have found this video being helpful to you. So that's it for this video. Thanks for watching, and I wish you all the best.